All right, good afternoon, everybody. Thank you for joining us today. I'm going to go ahead and get ready here and start our webinar. Recording should already be in progress. So as we go through today, feel free to send in any questions you have using the chat or the Q&A function. Chat is just fine. I know in the past we used to say always use the Q&A, but with the new changes they keep making to the interface, chat is just fine for sending in any questions you may have. So today we are introducing two new Wi-Fi 7 access points. This is going to complete our Wi-Fi 7 lineup for the time being. So we are fully fleshed out as far as Wi-Fi 7 access points goes. As we'll start here, we'll just talk a little bit about Wi-Fi 7, just a few brief slides. I'm assuming most of you are already rather familiar with it. So Wi-Fi 7 adds a bunch of new technologies that help make things primarily faster and just generally more reliable. So one of the ways that we get to faster speeds is we can use wider channels. So when 802.11a, B, and G came out back in the day, they were using 20 megahertz channels. 11n gave us 40 megahertz channels. Wi-Fi 6 gave us 160 megahertz channels, and now with Wi-Fi 7, we can use channels up to 320 megahertz in size on the 6 gigahertz radio and up to 240 megahertz in size on the 5 gigahertz radio. The next thing we do here is we have a greater QAM. We went from 1024-bit QAM to 4096-bit QAM. So that gives us about a 10 or 15% speed increase there. One of the other cool technologies that just began here with Wi-Fi 7 is called multi-link operation. The ability for client devices to be able to connect to multiple radios in the access point simultaneously, allowing for higher throughputs and lower latency, and a new technology called multi-RU puncturing. So the idea behind multi-RU puncturing is now we're using these wider channels, 160 megahertz, 240 megahertz, 320 megahertz. And the problem you ran into here is if you experienced any interference in any part of that big channel, it could cause all of the packets to get dropped or interrupted. So with multi-RU puncturing, we're able to use this big wide 320 megahertz channel and say there's interference in a specific 20 megahertz portion of that. With Wi-Fi 7, we can take that 320 megahertz channel, split it in two, and ignore the part that has the interference. So instead of 320 megahertz, you now have 300 megahertz with no overlap or interference. So it allows you to use those wider channels and take the benefits of using them without the risk of greater interference like you had in the past with older Wi-Fi technologies. So part of the reason we can do these bigger channels is because in the past, Wi-Fi was limited to the 2.4 and 5 gigahertz spectrums, which you see up there on the screen. And with Wi-Fi 7, we now have access to 6 gigahertz spectrum. So as you can see here, 6 gigahertz is in totality larger than 5 and 2.4 combined together. So this allows you to deploy more access points, more client devices without worrying about overlapping your channels and getting interference. So for instance here, with 5 gigahertz, you only had 260 megahertz channels available. And to use either of them, you had to overlap on the DFS spectrum, which in some places is not very reliable. And in a lot of cases, client devices do not support those DFS channels. So you would not be able to use the 160 megahertz channels. Where with 6 gigahertz, you've got 7 non-overlapping 160 megahertz channels. And any device that supports Wi-Fi 7 is going to be able to support any of those channels here in North America. Now, there are some trade-offs with 6 gigahertz. The first one is as a general rule of thumb, you cannot use 6 gigahertz outdoors. It is an indoor-only technology. The second challenge you have with it is 6 gigahertz because it's a higher frequency. The signal travels less distance than 5 gigahertz. So if you are upgrading your network to 6 gigahertz coverage, you may have to add more access points than you have currently to support the same coverage that you're getting currently. And then probably the biggest challenge with 6 gigahertz is very few devices to this day still support it. It is mostly your flagship cellular phones and your flagship laptops that support 6 gigahertz. Um, we ran into this question just the other day when we were launching our these new access points here, and it was, well, why are you doing 2.4 and either 5 or 6 gigahertz? And the answer to that is 2.4, despite the limited bandwidth, despite the interference issues you may run into. It is still the default that's out there, and a lot of devices still only support 2.4 gigahertz. Almost any sort of smart plug that you get or home automation device you get is only going to support 2.4 gigahertz. And what we found is out in the field, plenty of your industrial equipment, your warehouse scanner devices, and other sorts of devices like that still to this day only support 2.4. Many of them don't support 5 at all. And obviously, if they're not supporting 5, they're not going to support 6. So you still need that 2.4 gigahertz support and probably 5 gigahertz today to support those legacy devices and those lower end devices that are using, the cheapest chipset possible to keep the price down. So today's new access points are going to be part of our W series of access points. So at Zyxel, we've got two primary lineups of access points. We have our NWA series or N series access points and our W series. So one of the common questions we get is, I'm looking at the specs, your NWA and your WBE seem very similar. What am I getting with the W series that I don't get on the NWA series? So the answers to that are our WBE series or Nebula Flex Pro. So that means they come bundled with 1 year Pro Pack. The W series also support local wireless LAN controller. So that's something that's built into our USG Flex security appliances is the ability to act as a local wireless LAN controller. So that requires the W series. Our W series access points are also going to be where you find some of our advanced antenna solutions, such as dual optimized or smart antennas, both of which are in these new access points we're announcing today. The ability to do bridging with smart mesh. For the most part, the NWA series, with one exception, does not support bridging on smart mesh, where all of the W series does. We also have a technology called secure Wi-Fi, which allows you to convert a access point into a cloud managed remote VPN appliance. So that's something that requires the W series. We have a technology called collaborative detection and response, where our USG Flex security gateways can coordinate with the access points to help isolate threatening devices which come onto the network, such as a laptop that's been infected with a virus or worm. So that's something that requires the W series. And then we have, when you're using local wireless LAN controller, the ability to do GRE tunneling over IPsec, where all wireless LAN traffic on a certain SSID gets GRE tunneled to the security appliance before it gets allowed to access LAN at resources. So that again is something that's only available on the W series. So today's access points are our WBE510D and WBE630S. So these are both band flex access points. So this was something we first started doing with the Wi-Fi 6E a few years ago, and now we're continuing this here with our Wi-Fi 7 access point. So what does band flex means? Well, what this means is you've got an access point that supports 3 bands, 2.4, 5 gigahertz, and 6 gigahertz, but it only supports 2 of them at any one time. So there's 2 radios, whereas something like our WBE530 or WBE660S has 3 radios, allowing you to simultaneously operate in 2.4, 5, and 6. With band flex, you operate in 2.4 and either 5 or 6. So the question comes up a lot is, well, why are we doing this? And that goes back to what I was talking about earlier when it comes to the band utilization. At this point, most of your legacy devices out there do not support 6 gigahertz. So this is a way that allows us to achieve 2 things. It gives you the ability to buy a less expensive access point that supports Wi-Fi 7. So Wi-Fi 7 does improve performance on 2.4 and 5 gigahertz. So you get those benefits today. And in the future, when 6 gigahertz becomes more widespread, with a flip of a virtual switch in the interface, you can enable 6 gigahertz support for those devices when it's time for them. And the other benefit of doing it this way today, other than keeping the cost down, is it keeps the PoE power demand down. So in general, when it comes to higher performance tri-radio access points like the WBE660S, they require more power than 802.3 AT PoE devices put out. So instead of 30 watt PoE, they require 60 watt PoE. And most of you out there, your existing infrastructure probably supports 30 watt PoE, but doesn't support 60 watt PoE. So if you're going to upgrade to a higher performance Wi-Fi 7 access point, you're also going to have to upgrade your switches as well to provide higher PoE output power on a per port basis. So by going to simply a 2 radio device, we get that higher performance 5 or 6 gigahertz radio, but we can still keep the access point using your existing 802.3 AT PoE devices out in the field. So we'll start talking about the first device here. This is our WBE510D. So again, BandFlex radio. It's Nebula Flex Pro. It's part of our W series here, and it provides speeds up to BE 6500. So aggregated speeds between your 2.4 and 6 gigahertz radio are 6.5 gigabits per second on the wireless network, wireless to wireless communications. It supports multi-link operation, and it supports our dual optimized antenna technology. Excuse me. It does come with a 2.5 gig multi-gig uplink port, which is going to be your primary connection, and most of you will be powering this with PoE. We do also support powering this using a USB-C charger that supports PD power delivery as an option for you. So what is dual optimized antennas? This is something that most of our competitors do not offer. In fact, I don't think any of our competitors offer. And basically what happens is your traditional access point has been optimized to be mounted on the ceiling and uses an omnidirectional antenna to radiate the signal out in roughly an antenna or an umbrella pattern emanating out from that access point, covering the area below it. Now, the challenge is out here in the real world, you oftentimes can't always mount your access points on the ceiling, and you end up having to mount them on the wall where they're rotated 90 degrees from where they're supposed to be or how they're optimized to perform. So you end up sending a lot of your signal up into the ceiling, down into the floor where it's either lost or it can cause interference on those other floors depending on what your floors are made out of. So our dual optimized antenna technology comes with 2 different sets of antennas for each radio, one optimized for your traditional ceiling mount and one that's been optimized for wall mounting. So you simply go into the Nebula interface and tell it whether it's mounted on the ceiling or wall, and it will switch the antenna patterns to one that's optimized for where it's been deployed. The other AP we are announcing today is our WBE630S. This should be orderable through distribution by the end of this week, and probably at some of our distributors by the end of today or tomorrow. So this is a brand new access point for us, and this is going to be our most affordable smart antenna solution going forward here as we slowly phase out the Wi-Fi 6 access points. So this guy here is a BE 1200 or 1200 12300, excuse me. I'm apologize there. Speeds here, so 12.3 gigabits per second on wireless to wireless communication. So this is actually faster than our NWA130BE and our WBE530, which are tri-radio. So even though this is dual radio, the 5 or 6 gigahertz radio is actually faster than what comes in those. So you're getting better, faster aggregated speeds between both of these radios than you would get when you aggregate the speeds across all 3 radios on those other devices. So this has our smart antenna technology built into it. It has got dual 2.5 gig Ethernet ports on it. So one port is your PoE uplink port, and the other port is a pass-through port. So you can daisy chain connections, reducing the amount of cable runs you have to do to a room or area in the building. And just like the other access point there, if you don't want to use PoE, you can also power this device using any USB-C PD compatible power device. So this uses our smart antenna technology, which is something out there that's, you don't find on a lot of other access points at this price range. This is probably most similar for those of you that have sold other solutions out there to Ruckus's BeamFlex Plus technology. And the idea here is to increase the capacity or the number of users that can be connected to a single access point. It increases the coverage area, providing coverage over a greater distance. And a big part of this is the ability to reduce interference, especially in environments where you've got a lot of access points or a lot of users crowded into the same area, such as schools, business conference centers, things like that. So again, as I was mentioning earlier here, most of your access points are optimized with a single antenna pattern that's designed for the idea that you're going to mount this on the ceiling directly over the area to be covered. So what Smart Antenna does differently is instead of having a single antenna pattern or having dual antenna patterns like our dual optimized devices, we have an array of antennas that allows us to be able to switch antenna patterns. So we have hundreds of different antenna patterns that we can choose from. So we can automatically choose the antenna pattern that works best both for the client device we are trying to contact, but also allowing us to take into account other sources of RF interference and choose an antenna pattern that basically allows us not to hear that interference. So because of that, in dense RF environments, we can actually achieve greater than the theoretical maximum airtime utilization. So in general, 100% is your maximum airtime utilization, and in a dense environment, the best you're shooting for is somewhere around 95 to 97% airtime utilization. With smart antenna technology, with multiple access points, you can achieve airtime utilization up to as much as 140% of the theoretical maximum airtime utilization, allowing you to achieve faster and greater speeds with less interference, less drop packets, much more evenly distributed data performance across your access points. Now, both of these access points use our modern mounting bracket design here. So this has been designed to allow you to mount the bracket directly onto a wall or ceiling, and screw hole antenna patterns or screw hole patterns here to allow you to screw directly into a junction box or a outlet box on a wall to provide secure mounting. It also works with our optional T-bar clips. So if you've got a deployment where you're using drop ceilings that are being held up by traditional T-bar, you can clip these onto the T-bar, and then the mounting bracket itself will snap into that. And then the access point itself snaps into place. In order to release the access point, you need to use a screwdriver or pen to reach in between the access point and the wall or ceiling and hit a capture release there. So it gives you security of the device. A typical user isn't going to be able to figure out how to release the access point, but you as an installer can quickly and easily release the device if you need to remove it or do some maintenance on it. So both of these access points use our RF first by design philosophy here. So what that means is, in additional to your traditional signal, your EMI issues that you may run into, so we put shielding on the board there, we have additional shielding that's designed to filter out 4G and 5G interference. So a lot of people don't realize a lot of your LTE and 5G bands border on the 5 and 6 gigahertz bands that are used by Wi-Fi. And in indoor buildings where you're using a DAS system to rebroadcast your cellular coverage inside the building, those remote units inside the building, often using the same cable drops that your access points are, so end up mounted in very nearby locations in the building where it can cause interference with an access point. So our extra filtering here helps prevent that. Of course, both of these access points can be managed using our Nebula management platform, which is free to use for management. Both of these devices are W series, so they also come bundled with 1 year of our optional Pro Pack features. And both of these are compatible with our Connect and Protect service. So this is a UTM Lite service that you can buy on a per access point basis to be able to provide those UTM-like security features to your wireless users. So a lot of users are using this, for instance, if you're providing public hotspot access or public access to a wireless network, to provide some additional filtering to those wireless users to help protect them. And again, this can all be done through the Nebula Control Center, which gives you a single pane of glass, not only for access points, but for switches, our security appliances, and all of your customers. So where are these good devices to use? A couple good ideas here for you, or any sort of high density locations. Eventually you will want to move your high density devices over to 6 gigahertz. So this is an easy way to be able to do that once your users catch up or your client devices catch up to 6 gigahertz, because 6 gigahertz gives us so much bandwidth. You help eliminate a lot of those interference issues you run into today on 2.4 and 5 gigahertz. It's good to use for meshing. 6 gigahertz can provide great high-speed meshing, even when you're also using that technology to provide connectivity to your users themselves. And then any sort of high bandwidth application where you're trying to stream the fastest possible data without needing to compress it before transmitting it to reduce latency, great options there for you as well. So just in general, why was Zyxel networks for Wi-Fi 7? You know, we have been doing this for a long time. We have over 30 years of networking experience, and I think roughly 30 years of wireless deployments are coming up on that. We got started all the way back in the initial 802.11 days. We're making wireless products back then, back before 802.11 A, B, and G. We also have been very aggressive at being some of the first products on the market. So the first business class access points were us a few years ago. We are some of the very first to do these band flex type Wi-Fi 7 devices, and we were some of the very first to support MLO or multi-link operation when we released that through Nebula last summer. We have a great relationship with Qualcomm and some of the other chipset vendors out there. So we are getting some of the very first to be able to get access to the latest builds of their chips, the latest builds of their software, and to be able to integrate that into our firmware. So just in general, you know, the WBE630S, you know, excels as it comes to management, flexibility in how you're using it, support for smart antenna technologies for those really tough to deploy RF environments. So with these two new access points today, this completes, at least for the time being, our Wi-Fi 7 portfolio. So we now today have 7 different Wi-Fi 7 access points available for you, both tri-radio and dual radio as we launch today. So we've got products all the way down at the entry level of the market on the WBE510D, which I think today is the most affordable Wi-Fi 7 access point out there. We've got our WBE660S, our flagship high performance Wi-Fi 7 access points for those of you that need that performance or want to future-proof your networks today, and then everything in between. So no matter what you're looking for, we've got a Wi-Fi 7 access point that supports you. So with that there, that concludes today's webinar. So if you have any questions, do feel free to send those in. So far, there are currently none pending. So again, you can use the chat or the Q&A function to send those in. I do appreciate you turning out on a Monday, which is a bit of an unusual choice for us when it comes to webinars. So I appreciate you coming out today. I hope to see you at some of our future webinars. And as always, if you have some feedback or some requests, feel free to reach out to your salesperson, Jacob, Andy, or David, and they can either answer those questions or loop me or me in or our sales engineer Marcus in to be able to help answer those questions for you. I'm not seeing any questions coming in, so I'm going to go ahead and end today's webinar. Thank you for joining us today. Oh, we've got a question here from an anonymous attendee. Where is that feature in Nebula configure access points as wall mount? So that is a good question. And off the top of my head, I don't remember exactly where it is. I think you go into the access point itself and toggle that on, or it's under the radio settings. It's one of those two. So it's either under configure wireless radio, or it's under, you go to the device itself and it's on that screen there. I know for sure mesh is on the device page itself. So it's one of those two, and I'm sorry I don't know off the top of my head where it is. But if that's something you still need help after today, if you go back in there and my answer was wrong, it's not under either of those, reach out to your sales guy. They'll be able to help you out. We also have our tech support. So you can always call our 800 number and talk to somebody during business hours based out of our Anaheim office here. If you are one of our reseller partners, you have joined our partner program, there is a special phone number just for our partners, which gets you priority access to our tech support team so they can help you out there. Or again, just drop an email to your sales guy, drop an email to me. My email is Sean R, and Sean is spelled phonetically, so it's SHAWN, the letter R at Zyxel.com. And I can pull up Nebula and find it for you and let you know that way as well. Feel free to also email me questions directly or feedbacks on today's webinar or feedback on additional webinars you would like to see us do in the future. With that, though, I'm going to go ahead and end today's webinar. Thank you for joining us, and I hope to see you on one of our future webinars. Thank you.